Alrighty, everybody, welcome back. So we hope that you had a really great couple of networking sessions. You were able to meet people, you were able to talk about how y'all collaborate, how y'all move forward, and just how you can partner together for some more comprehensive or more complete solutions to problems that people are facing. So we're going to have our next session now, and we're going to have a presentation by different offices under the Navy. They're going to share some information with you about how they operate, what they fund, what are the critical problems that they, as you heard in our last panel, the Navy and all the Department of Defense service components typically operate under a, we have a problem, we need a solution, we need you to help us solve it. So the Department of Defense is one of the largest into the SBIR and STTR programs. Typically, the DoD uses these programs as a way to procure solutions for those problems that they are facing within specific domains or areas. They need novel products to address these issues, and they rely on small businesses like you to create those products for them. So we're going to have a few different DoD representatives, Roberto Sanchez, Sean Slade, Emily Novak, Jennifer Greenwood, Ryan Blandino, Richard Park, Larry Branthover, and Douglas Marker that are going to go through some solutions, and they're going to share some information. I'm going to share a slide deck really fast, so give it 1 second. As it uploads to the system. Seems to be going a little bit slower than normal, so I'm going to share a screen instead. So let me make sure that is showing correctly for everybody. And Jennifer, you are the first one up.
Awesome. Thank you, Del. Good afternoon to everybody. I want to take a second real quick and thanks to the New Mexico FAST program, Del and Dana for setting this event. It's an awesome event every year, and I'm thrilled to be a part of it. Sorry we weren't able to be there in person, but I'm really happy we were able to continue this through the virtual environment. Hopefully next year we'll be able to return to the in-person style event. I represent the Program Executive Office for the Unmanned and Small Combatants, otherwise known as PEO-USC. Those aren't my slides up, but I'll wing it. So one of my slides will show all of the PEO-USC mission set. If you want to go to the next slide, Del, that would be great. So this is our PEO-USC portfolio. As you can see, we have a really diverse set of missions. I know some of them are kind of tough to see on here. And we recently added 2 new program offices to our mission set. There was a reorg within NAVC that aligned a bunch of different program offices. We increased by 2. They're not represented on this slide. It's kind of so recent that we haven't had a chance to update the slide yet. But PMS 408, which is our Expeditionary Missions Program Office, was added. And PMS 340, which is Naval Special Warfare, was also added. So hopefully next time I'm presenting, those will be another little piece of our pie chart here. But as you can see, we do a lot of different things. There's a lot of different program offices, a lot of different product lines in PEO-USC. So our topics represent a very diverse set of missions. So for example, we have PMS 406, which is they're representing most of our topics this year. They're our Unmanned Maritime Systems Program Office. They're responsible for the UUVs, unmanned underwater vehicles, the USVs, unmanned surface vehicles, and on this chart, it also shows MCM USV, I think is on there. That was moved to PMS 420, which is our LCS mission package program office. That's going to be a part of the MCM mission package once it deploys on LCS. We also have PMS 495, which is our mine warfare systems program office. They do all the mine hunting for the Navy. Then we have 3 or 4, depending on how you count it, we have 4 ship systems program offices. PMS 501 is our LCS fleet introduction. They're responsible for purchasing and building the LCS platforms. PMS 505 is our LCS sustainment and modernization program office. They're responsible for maintaining and upkeeping the LCS platforms. PMS 525 is our LCS international program office. They're responsible for exporting the LCS vehicle. We also have a newer program office and a newer platform that came on board, which is PMS 515. That is the new fast frigate program. So as we're starting to see them, they've announced their platform. So we're starting to see them kind of do more SBIR activities. So I'd look for them to do more in the future with SBIR. They've been kind of quiet lately, but I would expect that they would start to pick up their involvement in the SBIR program. Our topics really represent the diversity of our portfolio, undoubtedly. One of the biggest challenges we have in PEO UFC, and I think most of the folks on the panel would be able to agree with this as well, that size, weight, and power is a huge problem. And as you look across our portfolio, we have very, very small things and very, very big things. So we look for, things that can be scalable from very small to very big as far as the size, weight, and power considerations go. So on UUVs and USVs, some of the smaller vehicles, we need, obviously very light. So the size and weight, you want to be able to fit in those different size footprints. Weight is also a huge consideration because, once again, we have those heavy, put something too heavy on a USV, it's going to sink. So we want to make sure that we're managing those weight considerations. And power. So working in the USV and the UUV realm, we have a lot of issues with getting power to those vehicles. How do you power them? We want to be able to have them out to sea for a long period of time. We would like the large USV and the medium USV to be able to go out and deploy for, months at a time. How do you can constantly fuel them so they can maintain that mission? So that's an issue. How do we, do we bring them up and surface them for refueling? Can we, for UUVs, is there a beacon we can put out there? Is there some sort of power source that we can put in the ocean? So we're looking at all sorts of different power sources for the vehicles to kind of keep them moving and keep them in the mission so that we don't have to continually bring them in and fuel them. We're also looking at ways of maintaining them and monitoring them. If a fuel pump goes down on an unmanned platform, how do we get that back? If, hydraulics or something go down, how do we get that vehicle back? How do we fix it? So we have to look at those different considerations on maintenance of those, maintenance and upkeep of the unmanned systems. So that's a really, really big challenge for us. Another thing that we have a big challenge with, and there's a topic in our BAA this year that addresses it, is communications. If you're familiar with the LCS, you know that the mast is not very tall. It's a very low mast. So we can do line of sight communications, but over the horizon communications is very, very difficult because of that short mast. Now, if you're factoring in a USV into the scenario, we have even more problems communicating with the USV because the USV is also very small with a very small mast. So how do we get these different vehicles talking to each other so that we can carry out a mission and keep everything moving the way it's supposed to? So communications is very challenging for us, and we have one of the topics addressing communications. That's a very critical need for LCS. So if anybody out there has any good communications relay technologies, please feel free to propose it. Another one that I would like to point out that's probably a very critical item for us is autonomous anchor handling system. one thing that we're realizing as we start developing these unmanned systems and start going through the ConOps of how we're going to deploy them, we're looking at things that you don't really think of. Very simple, things for a manned platform become very complex in an unmanned environment. So something as simple as anchor handling becomes a very anchor handling topic. How do we drop anchor? How do we, decide where to put the anchor? Those kind of things are very critical in PEO USC. All of our topics, though, are still very mission critical. So when we develop them, we make sure that we have that transition program office in mind. So we make sure that every topic has a home before we put pen to paper. So I've picked out a couple that are kind of high interest items, but all of them are equally very critical to the PEO USC mission. Please feel free to reach out to our topic authors. They are very knowledgeable and there to help you, and they're very willing to support any new technologies coming in. So we're very excited to work with you. Let me know if you have any questions, and I will turn it over to Ryan or whoever is next.
Yes, let's go back, and Ryan, thank you for being able to work through the issues and join us here. So you should see your slides to talk to now if you want to talk to them, or just kind of talk about the story about your PEO.
Yeah, of course. Glad to. Can you hear me all right?
Yes, we can.
Okay, perfect. Just wanted to make sure I did a quick comms check after some technical difficulties, but glad I'm coming through loud and clear. So good afternoon, everyone. My name is Ryan Blondino. I'm the technology manager for NAVSEA's HQ and Directorate. So we have a couple slides here today. We'll be talking at a high level about HQ and Directorate's portfolio stakeholders, a little bit of how we operate, and even some of our strategic alignment for our FY 21.1 topics. So let's go ahead and move on to the next slide, please. Okay, so just up first is our command leadership org chart. And the reason why I'm showing this right now is because unlike some of the other technology managers that are here today, HQ and Directorates doesn't quite neatly align itself to one of the major PEOs that you likely see in the top left-hand corner there. Instead, HQ and Directorates is focusing on the engineering, design, and delivery requirements for a wide variety of groups that you also happen to see here on this org chart. So that includes groups like CO5 Systems Engineering, the shipyards, the Naval Ordnance Safety and Security Activity, or NOSA, and even diving and salvage operations. So to give you a little bit more information about, how we interact with some of each of these and what their mission is, I thought I'd kind of just touch base on a few of them. The first being CO5's Naval Systems Engineering and Logistics Directorate. So they're actually responsible for the expertise and technical authority that's necessary for us to design, build, maintain, modernize, and even dispose of Navy subs, ships, and associated warfare systems. We're also working heavily with the shipyards under CO4 as they have the important mission of getting ships to sea and keeping them ready. They're the preferred integrator for logistics, maintenance, and industrial operations. And with the potential for fleet growth in the future, it's critical that we make sure we're providing the relevant technologies to the shipyards so that we can maintain and sustain our fleet on a regular basis. Now, NOSA is a field activity of NASD that provides ordnance safety for the Navy enterprise, which ranges anywhere from their technical authority with respect to explosive safety all the way to technical policies, procedures, and design criteria. Then lastly, we have our diving and salvage operations group, which is really providing, cradle to grave services all the way for things like, diving equipment, salvage, deep ocean search, and a litany of other things. So they're also covering things like basic research through prototype development, acquisition, operations, so on and so forth. So in summation, unlike a lot of other folks here today, we are a cross-cutting portfolio, not just from a technology perspective, but across from an organizational perspective as well. We span a wide variety of groups, and therefore we have a wide variety of stakeholders and subject matter areas. If you can go to the next slide, please, that'd be helpful. All right, perfect. So we wanted to show this slide as well, just because it's more of an in-depth review of our specific stakeholders, and it looks at that granular level of four organizations that I mentioned before. So we're working with 11 different offices across DO5, and that can range from anything from like additive manufacturing to cybersecurity to a number of other different subject matter areas. And we also work with 3 teams from NOSA, 6 different offices from diving and salvage operations, as well as the 4 shipyards that are under CO4. So what we typically do is we work with all of these stakeholders to develop topics that can fill a gap or need. Those technical topic authors should be working with program offices and acquisition authorities to draft topics that the program office would be willing to utilize their funds to acquire if the technology is successfully developed. So we encourage our technical topic authors to incorporate the end user's input right at the beginning so we can increase the likelihood of success and improve our chances of transitioning the technology to the warfighter. Having a customer lining up the appropriate funds and contracting resources throughout the life of successful projects helps ensure a seamless transition into phase 3 or ultimately the commercialization of technology. Now, for this particular cycle, what we have going are 5 different topics. I won't deep dive each individual one. We have a wide variety of things that are taking place, such as the efficient data management to improve Navy maintenance and ship operational readiness, which is very software focused. And then on the other hand, we have very niche focused things that also have heavy hardware components. Things like the lightweight diver handheld underwater hydraulic friction stud welding system for 5000 series aluminum. Definitely on opposite ends of the spectrum from a technology standpoint, but all very helpful. So what I want to bring to everyone's attention, I suppose, in summary, is that despite the variability in our desired technologies, our portfolio is aligned at a strategic level. So our FY21.1 topics are leaning pretty heavily into sustainment-focused technologies that's going to support the NDS or the National Defense Strategy's desire for modernized distributed logistics and maintenance. So these strategic technologies will enable the on-time delivery of ships and submarines and even afford us a culture of affordability, both of which are key tenets of NAVSEA's campaign plan to expand the advantage. So our ability to deliver ships from new construction and out of maintenance availabilities on time is critical to meeting fleet needs. In order to do that, we have to modernize our sustainment capabilities and take advantage of cutting edge technology in the areas of autonomy, laser and optical scanning, conditions-based maintenance, enterprise data management, and a lot more. So with that in mind, I thought I'd actually just hone in on a little bit on the efficient data management to improve Navy maintenance and ship operational readiness topic. That's topic N211-074. So that one's actually been very popular as it is software oriented, and it's actually a key enabler for other technologies. I mean, the potential applications are expansive and pretty far reaching and could even revolutionize maintenance activities. Now, the other topics, again, as I mentioned, have, more of a hardware focus, so therefore they might be a little bit more narrower in scope and have very particular uses, but all of these topics are excellent, nonetheless. That efficient data management particular topic that we're speaking to right now, its overall objective is actually to develop an efficient and secure data management software application that would enable things like conditions-based maintenance and reliability-centered maintenance. So that we can, sustain and maintain and modernize our ships, aircraft carriers, and subs. Now, a comprehensive understanding of a ship's material condition is critical to maintenance performance because, shipyard personnel are typically the ones who assess the ship's material condition, whether that be through ship checks, ship logs, and ship visits, which in many cases reveal even further unanticipated maintenance issues. So we're, as the Navy, looking for data analytics capabilities that will be able to provide us, real-time ship performance and component level data that could then be securely shared between the ship and the shipyard that's ashore in order to, proactively align some of those shipyard resources so we can reduce costs and delays in the schedule. So coordinating these, technologies such as this and this particular topic across all of the PEOs, shipyards, and engineering directorates is really essential if you want to be able to transition these technologies to the fleet. So I definitely encourage everyone to go into, the BAA and look at the topics individually, look at those individual requirements to see if you have an opportunity to propose a particular technology for any of those topics, as they will all be very beneficial to sustainment actions and maintenance capabilities. Appreciate everyone's attention today, and definitely keep an eye out for any of those opportunities for things specific to secure data management, digital threading, digital twinning, again, scanning, various forms of welding, whether it's underwater aluminum friction welding, and even NVDC or medium voltage direct current capabilities. That's pretty much everything for me today, but thank you so much for your time today. I really do appreciate it.
All right, thank you, Ryan. Doug, if you want to go ahead with your PEO and your topics.
Okay, welcome everyone. I was talking to Del just before we started, and he told us that with all of the satellite, I don't want to use the word satellite because it makes it sound like it's going through satellites, but all of the various stations which are listening to this, so there's a total of potentially 1,093 people who are listening to this. So this is awesome that we have such an interest. This leads into something I wanted to talk a little bit about. If you notice the word NAVC, there's several syscoms within the Navy. Just a couple of others is used to be SBIR, now it's USC, and Navair. NAVC is one. And several years ago, Dean Putnam, who's the program manager over the SBIR, STTR programs within NAVC, said, hey, we need to reach out to other areas. And so it's my understanding that this process that we're going through right now was initiated by him. NAVC did this at different times. We invited other people to participate. I think Dean needs to be recognized for his vision of working something like this. We've got 2 sessions like this. Last week we met where everything was broadcast out of Boston, and this week we're in Albuquerque. And I personally, and I'm sure on behalf of Dean, thank you very much, the people here at Albuquerque who've made this possible. Now, to help you understand a little bit about what you're seeing or hearing today, we have within NAVC headquarters, you've already heard from them. We have PEO carriers, PEO USC, PEO ships, PEO subs, and PEO IWS. I'm biased about IWS because I like to say that the other platforms, pretty much except for headquarters, are working with the actual platforms, the ships, whether they're subs or destroyers, LCS. And IWS, Program Executive Office, Integrated Warfare Systems, is responsible for, actually we have the acquisition authority to purchase all of the combat systems and the elements that go into them. And by elements, I'm talking about things like guns, missiles, radars, projectiles, sonar systems, EW systems. And so when those go aboard these various ships, we turn them into combatants. And there's a lot of interest in the weapon systems that we are introducing into the fleet. And in the words of Admiral Rempt, I worked under him many years ago. I went to him and I was talking about how we were working to develop technology that would, basically on the graph that I had, it showed that it was matching the threat. And he said, Douglas, we want to exceed what the threat is. And we have a lot of systems that are, a lot of combat systems and ships and things that are being built, but we want to make sure that we go forward. And the SBIR program is an excellent program to help us tweak, I guess you might say in some cases. They're very small programs, but they can lead you to multi-million-dollar efforts to keep our fleet ahead of everything else that's in the world. And there are priorities that have been set down upon us to encourage us to know where we should work. So let's go to the next view graph. This is the IWS programs. If you look down in the lower left-hand corner, we have 140 programs and projects. If you look at it, I'm only going to talk about 4 of these areas because that's where the 13 topics that we have come from. If you look at about 4 o'clock, you can see it's kind of hard to see on the screen, at least that I'm looking at. That's IWS 2. Most organizations that you look at in you'll see terms like PMA, which refer to aircraft programs, PMSs. Those lead-in numbers are kind of hidden within IWS. We're divided into what we call major program manager organizations. There's a captain who is over that, and as a consequence, like my wife walked in on us here. We are divided into these major program groups of IWS 1, 2, 3, 4, 5, 6, 7 has been disbanded, 8 on up through, I believe we may even go as high as 12. Each one of these work on specific areas. And notice how we're tied into the multiple platforms. At about 3 o'clock, you can see various big decks and carriers that we work with. But the ones I wanted to talk about, let me get back on subject here. At about 4 o'clock, that's IWS 2. POIWS 2 is involved in systems that are electronic warfare, active and passive. They are the acquisition authority for all of the surface Navy radars, from the very high-powered radars associated with the Aegis system, the SPY-6 and stuff, which is a big one coming down the pike, down to navigation radars. They also, if you look at this diagram over there close to the edge on the right, there's Helios. We are actually in the throes of and the development of a ship-based high-energy laser. This is very exciting, and I'll touch a little bit on some of the TPOCs or some of the topics that are coming out of there. At about 6 o'clock on this diagram, and going a little bit to the left, you'll see IWS 3. IWS 3 is the organization which is responsible for programs associated with the missiles, the launchers, guns, and projectiles. And right now, both for projectiles and missiles, we've got some very serious areas that we want to pursue. And I'll get into that, but I'll just mention one that we're very much interested in is because of the threats that we are encountering or that we are aware of, we are going to higher and higher velocity. So we're looking at hypervelocity stuff. And what happens when this happens is you put tremendous thermal stresses upon your missile and even upon your projectile. And if you've got a nose cone that you've got a sensor in, you cause major problems there because of the heating of that particular portion of the missile. The next group that I want to talk about is IWS 5. This, as all others, is a very interesting group. They came to POIWS when it was formed. They came from PO Subs. They were a group that did a lot of the science and technology, and that's what they still do. So within this group, we are working towards, we work with programs that are associated with anti-submarine warfare. We work with sonar that's on the hull of the ship or vessel or submarine, and also towed arrays. And we've got several topics that are coming out of this organization. This organization is probably our most successful as far as transitioning into phase 3s. If you go to 9 o'clock, you will see IWS 6.0. The particular program there that is, I think, very impressive and very exciting is CEC there. It's a large rectangle that you see. CEC stands for Cooperative Engagement Capability. I'll just briefly say that this project is something that is just unbelievable. The signals from radars and different sensors are all sent out on links to all of the ships. And there we have each one of those ships has the same set of algorithms and applications, and they develop a composite track. sufficiently accurate that any one of them, depending on which one is designated, knows where the incoming threat is, and depending on which ship is closest or can intercept it, that one is given direction to go ahead and fire and intercept that thing that's coming in towards them. So I wanted to point out that we in IWS have what we call an S&T IPT. Each one of these MPMs that I listed here have representatives on that. And when we get to the SBIR cycle, when the call comes out for topics, we send out a call within our organization. The representatives on the IPT, there's one per MPM. They work with their respective MPM personnel, and they come up with areas where they want to improve something or do something that a small business could handle. We have to make sure that it's on the scope of the SBIR, $1.7 million for phase 2 over 3 years. So we need to pick projects that are the right size. We ask them, each MPM, to come in with a prioritization, and then we go through an adjudication process. There are a couple of questions. I'm the technology manager within PUIWS, and as we review this, we also have the chief technology officer there. But I ask 2 very specific questions on every topic that is presented. One is, if this is successful, will it transition? In other words, is there funding that is available at the end that would will it go into a phase 3? That is key. We want to make sure that, and we also want to make sure that it meets the areas which are of significance to the Navy. For example, right now, we are receiving guidance across the Navy on what are called the National Defense Strategy, and there's some things there such as build a more lethal force, prepare for war, sustainment and readiness. These are very high level. Then there are secondary areas that we ask our people if they're meeting those or they fit into this somehow. And that's the lethality, agility, resilience of the force, operational concepts, and so forth. And then there's another group, and this one I think pertains more to you folks because these other things are very top level, but they are areas that we're interested in. And that is the technology priorities. And as I interviewed in one-on-ones, I pointed out that within IWS, and this would be of interest to you as companies as to whether you have the expertise to address the topics that are in our organization. In other words, ones that you might want to put in a proposal on. We are very interested in machine learning and artificial intelligence. And I'll talk a little bit about how we are interested there. We are very interested in directed energy. The railgun is actually in IWS 3. We are interested in just general warfighting requirements, which isn't really a technology. We're interested in sustainment and maintenance. In other words, sustainment, we want to make sure that CIWS or that radar is going to be available a significant amount of time. We are also interested in quantum science. This is a new area. And we've got one topic in that area. So to give you a feel for the success of requiring or asking these questions of, does it meet a priority? And also, is there going to be funding at the end, SBIR, phase 3 type funding? POIWS typically has a percentage, it varies right now between about 48, and we've actually, a few years ago, we were actually as high as 56% of all of our phase 2s had received some type of phase 3 funding. That's money other than SBIR, which means that if you get a project with us, you have a very high probability, we feel almost a 50% probability that there's going to be some additional funding coming to you. So I think that most of you are interested in that kind of thing. So let's go into the next few graph. IWS2 next. I'm not going to go into the detail on most of these. These two projects here have to do with electronic warfare. In our electronic warfare, we have both passive and active systems. And in this case, the two topics that we have, one's entitled Electronic Warfare Operator Workload Organization and Sharing, and the other one is Electronic Warfare System Alert Monitoring, Prioritization, and Display. Problems that we are having is the operators are being inundated with information. We want to see if there isn't some way that we can alleviate some of the pressure upon them through some machine learning and artificial intelligence to handle everything that's coming in on top of them. And I think the next one is geared more towards the fact that there may be new systems, and we want to make sure that we are alerting correctly. If there's something we've never seen before, we want to be able to handle it. The next one I'm only mentioning is called Fast and Effective Readout of Steering Focal Plane Arrays. This is getting down to the electronic components that go into a system. The only reason I bring this up is that there's transition and there's transition. In this case, the transition will be going to a future naval capability over at ONR. We have this also in IWS-5. There's element or components where the technology that you would develop will go over there first. I like to see it going actually into the fleet, actually into a program. And so you need to understand that we are looking for, in the case of SBIRs, something that at the end is at a TRL6. And that way, the program manager over that particular element can proceed to do field testing, raise it to a 6, a 7, and an 8, and also do the verification, validation, qualification testing that they need to do to go forward. So in the case of STTRs, we're looking for things that get up to about definitely a TRL5. We're a little more lenient there because we realize that STTRs require that a university work with them. Just a note on that area. Let's go on down to into the next one. That one there. Notice here the high temperature, low dielectric, constant ceramic fibers for missile applications. I kind of touched on this before, but I want to reemphasize that because of the high speeds that we're getting, we're going to be demanding of our projectiles and our missiles. We need to be able to handle high temperatures because of the heat that is the nose of the fins encounter. But we also need to make sure that the structure is maintained as we go forward. Avoid warping and just for a formation of some kind. The dielectric aspect of it has to do with sensors that are carried on some of these, on particularly the missiles. We design these things such that those frequencies can exit the nose cone, and so we need to have something that will work at these higher velocities we're going to. Something that I want to emphasize here is when you look at the BAA, contact the respective, there are two numbers there, two phone numbers, or at least I assume that they used to have them, contact them and talk to them. First 30 days before the actual solicitation is released, there's an opportunity to talk to the subject matter experts and find out exactly what is needed and get a feel for whether or not your technology and your ideas are consistent with something that has a probability of being accepted if you submit a proposal. Let's go on to the next one. PIWS 5. These folks are working with, we've got two training programs here. One of the problems that all of us have is sailors could be trained onshore, and we do have training facilities, but once they get on the ship, it's amazing how quickly the sharpness of that training it dissipates. And so we need to have ways of training them on the ship. I don't know specifically whether these are doing that, these two training topics here, but we're trying to make them more realistic through artificial intelligence and machine learning. We're trying to make it appealing to the sailors. A lot of these sailors have come into the Navy having played with computer games. And people get almost addicted to these games because they're trying to excel. And so we're looking at training that is realistic, that uses actual data, and that's where I think a lot of the artificial intelligence comes in. We want it to be different so that they don't, the sailor doesn't learn all of the answer is going to be this. We want it to be unique and such that it keeps their attention and it keeps their acumen sharp as they go forward. Let's move on to, let's see, let's go on to the next, and that's next. We're going to skip through several of these. I think I want to get down to there, this one. One of the big challenges that we have in the military is what happens if GPS doesn't work? And there are a couple of reasons why, well, I guess there's more than two, but there are two big ones. One, they could be potentially jammed. The other is that the satellite could be potentially taken out. What do we do and how do we navigate in the absence of that? I find this topic to be very fascinating. There are places, land-based sites, and if you can read it here, but we're looking to do, I'm just going to read it. I don't normally do that. We want to develop receivers and algorithms that employ very low frequency radio signals from existing USG ground stations to determine position and velocity information at sea on a U.S. Navy ship or submarine. Even the submarines would benefit through this. The next one is related to this same thing. It's working with the same problem of making sure that we know where we are wherever we're navigating. And here we're talking about an atomic inertial sensor as an alternate position source. So I think that that's where I want to close out. I hope that I've given you enough information so you understand what our organization is, and I hope that I have particularly given you some areas that of expertise that you'll have a better feel for which topics you ought to look at. We wish you well and success in your submittals, and we look forward to them. I'll turn the time back over to Del.
Alrighty, Doug. Thank you very much. So next up, we have Emily Novak. Emily, if you want to take it away.
All right. Thank you, Del. Good afternoon, everybody. I'm Emily Novak, and I'm the Teamship's SBIR coordinator. I have worked with the program for about 6 years, and I certainly miss coming to New Mexico because I'm based out of DC, and it is freezing here. So I'm sure it's a little bit warmer over there. But on the very first slide, I wanted to draw your attention to why we call ourselves Teamships. And I said I was the Teamships coordinator, not PEO, and that's because we're an organization that's made up of both PEO ships and C-21. And so I drew a circle around it just to kind of highlight that relationship. And what PEO ships does is manage the new construction, design, and acquisition for destroyers, amphibious ships, boats, and crafts. And then NAV C-21 is the lifecycle management organization. So they do all of the modernization, maintenance, and training needs for the fleet. Together, they work to design, acquire, and support the current and future surface fleet. So one builds the ships, and then the other one kind of maintains and keeps them going and does the training. If you go to slide 2, this one gets a little bit more into the specifics about Teamships, and it shows our setup with all of the program offices and the leadership. And so just a quick run on how it's broken out. On the left side where you see the blue boxes, those are where the PEO ships and their program offices reside. So they're organized by program offices that represent different ship classes, and again, they're responsible for acquisition and new construction. And then on the right side where the green boxes are, it's the C21 program offices, and those are the ones responsible for modernization, maintenance, and training. In the very middle of the slide, I have a circle around Teamship Staff, and that's just to show where the SBIR team for Teamships is aligned. We are in the Science and Technology office, and we work out of there and then work with all of the different program offices. We have 11 program offices that participate in the SBIR program. I know there's more boxes than 11 on that, but we do meet with 11, and we meet with them monthly. Each of the program offices has an SBIR lead. And so when we do our monthly meetings, we will review the active SBIRs, we'll bring them new topics, new technologies that might be of interest. We could bring them ideas from other PEOs that are going on, like active SBIRs. And then also we'll find out if they have any new topic ideas. And one of the things that we like to do is when we have the one-on-ones like today, we'll bring technologies that small businesses present to us and see if there's any application in their program office, and maybe we can set up a brief with them or see if there's need for a topic that can go out. So we really like our monthly meetings with the program offices, and we may talk to them a little bit more frequent. But the next thing I want to do is speak a little bit about how the topics are released and how we bring in technologies from small businesses. So it starts with we're pulling the resources or funding together from the different program offices, and there's a pot of funding. Program offices will submit topic ideas, and those topic ideas are the ones that go out to small businesses for solicitation. Well, welcome back, everybody. I'm glad I didn't click out of my camera and turn it off. That was my one fear of this, but I'll get back into the talk. And I was on how we develop our topics, and we pull in the small businesses' ideas. And what we do is we pull the resources together of the SBIR funding from program offices. And when program offices submit topic ideas to us, we'll prioritize them and then develop them into topics that go out for release to you. So this is more than a year in the making. So it takes about a year for us to develop a broad agency announcement topic and put it out to you. We are only putting out topics that come to us from a program office. So if small businesses come to us with ideas or they really want a topic to go at, we would have to work it through a program office, similar to what USC and other of the PEOs do. One other thing that we will do is we will take ideas. Small businesses, you guys all have technologies that you're looking to find a home in a PEO, or you're looking to find a home in a program office. And what we can do is if you've had a previous SBIR and there's a need from a program office, we can take that and potentially do a reach back and revisit an older SBIR that you've had. Or if you have an active SBIR, we can see if there's room to put funding on it and do some tailoring and development for a specific program office. So there's a couple different paths to getting your technologies into a program office and bringing them to us. So one thing when we're doing SBIRs, Jen mentioned this, POUSC mentioned this, but one of the difficulties is size, weight, and power, but also cost of systems. So ships are, we're looking for solutions that are cost effective. So if a solution is really expensive, it can be a little bit difficult to find a home for it. So that's just one of the concerns we have. Another thing we really look at is it can be a little bit difficult to match up topic development timelines to ship delivery schedules. So you know that in the new construction side, they have their schedules and milestones, and what we're trying to do when we're developing our SBIR topics is somehow align and plan to insert technology or find a good path to get them into the new construction ships. So that can be really tricky since the timelines don't always meet and it takes so long to develop the topics. So sometimes we have two new ship classes that might be coming up. They're large surface combatant and light amphibious warships. So even though we don't have any topics specifically targeting them, we're already thinking about what existing SBIRs we have or what technologies are out there with you guys that when they're ready to take SBIR technologies, we can present it to them. So with that being said, the BAA that we're putting out has 6 topics, and I'm not going to go into any of the specific topics, but if we had to group them in 3 general categories, they would fall under shipboard integration of unmanned vehicles. We have a launch and recovery topic with LPD 17 for the PMS 317 program office. We also have an unmanned aerial vehicle handling system for ESV, which is in PMS 385. The second category would be next generation electrical capabilities. We have a laminated bus bar topic from PMS 500, which is DDG 1000. Then we also have a ground fault detection topic out of PMS 320 Electric Ships Office. And then the third category would be shipboard material solutions, where we are looking for a composite material system for PMS 377, which is the ship to shore and LCAC program office. And then also a non-corroding flight deck tie down out of PMS 400D DDG 51. So if anybody thinks they might have a technology that they'd like to bid to, we'd encourage you to look at the Friday's announcement. And if you have any specific technology questions or you want some clarifications, those topic authors will be the best people for you guys to reach out to. And then likewise, if you have any program specific questions or you still want to find out more about ships, please contact me. I would love to meet with you, as well as the other people on my team, 2 other team members. We'd love to hear about your technology. So thank you guys so much for listening, and I will turn it back over to Del.
Alrighty, thank you, Emily. And everybody, hold on one second while I fix something with the screen share. But after Emily, we should have Richard Park. Give me just 1 second, Richard.
Sure. Okay. Great. Okay. Okay, good afternoon. My name is Richard Park. I'm the technology manager at PEO Aircraft Carriers. Before I start, I just want to mention that I only have 2 slides. And the reason for that is because these are the only 2 slides that were approved for public release that were available to provide for the summit for my talk. So forgive me if I'm a little bit short on my visual aid side of the talk, but I'll give out as much information as possible on how PEO Aircraft Carriers is set up and how we handle and execute SBIR STTR project. So with that, if you could go to the next slide, please. Okay, so this is our PEO Aircraft Carriers org chart. And if I point your attention to the upper center portion of the slide there, so PEO Aircraft Carriers, otherwise known as PEO Carriers, is led by Rear Admiral James Downey. He's the Program Executive Officer, so he's the PEO Aircraft Carriers. And the civilian section, or the civilian lead of the organization, is Executive Director Mr. Robert Shabak. And as you work your way down in the org chart, the PEO Aircraft Carriers front office consists of 3 offices: Office of Chief Technology Officer, Chief Financial Officer, and Chief of Staff. And myself, as a technology manager, I fall under Chief Technology Officer, the blue box as shown on the left-hand side. Now, PEO Aircraft Carriers has 3 program offices under its wing. They're divided into 2 categories: in-service carrier program office and new construction carrier program office. So PMS 312 is our in-service aircraft carrier program office, and they're responsible for overseeing all the management, or the maintenance and upkeeping of our aircraft carrier fleet in the Navy. And so they're responsible for the 10 Nimitz class carrier that we have in the fleet. And the other two program offices, PMS 378 and PMS 379, are the new construction program offices. So they're responsible for overseeing the actual carrier constructions and technology integration onto these new aircraft carriers that are built by Newport News Shipbuilding, which is our sole carrier building shipyard in the nation. So the PMS 378, they're responsible for overseeing the completion of our newest aircraft carrier, USS Gerald Ford. And PMS 79 oversees the building of the CVN 79, which is John F. Kennedy. And they also oversee the contract awarding of the two other future aircraft carriers, CVN 80 and CVN 81. As you can see, for each of these program offices, that we have a small business advocate. So this small business advocate are the deputy program manager for each program office, and they're required they're required by the direction of the Assistant Secretary of Navy for Research Development and Acquisition to be the program office's the program's small business advocate. So their responsibilities include fostering increased engagement with small business, and also work with the prime contractors to push more small business effort. So they're really they help to establish a strong link between the program office and the small businesses. So at this point, I just want to point out that PEO aircraft carriers, unlike the other PEOs, we have a small SBIR, STTR portfolio compared to other PEOs. And the reason for that is because majority of our new technology development for both in-service carriers and new construction carriers are initiated and managed by Newport News Shipbuilding. So their R&D department, under the auspices of the PEO carriers and its program offices, execute a lot of those efforts. And I also want to point out that PEO carriers get a lot of the new technology product from PEO integrated warfare systems, and we get our planes from our Naval Air Systems Command. So the leads for those organizations, as you can see on the org chart, are closely aligned with the leadership at PEO carriers. So one may ask, how's the transition of a new technology executed or handled at PEO carriers? So to answer that question, it really varies by technology. But in most of the cases, the transition path or the method is really driven by how to best meet the requirement and the needs of the program office that has committed to being an acquisition sponsor of that technology. It also involves working with the primes, the prime contractors for the system technology, and also in our case working with the Newport News Shipbuilding. So with that, I'll move on to the next slide. So as I had mentioned, that PEO aircraft carriers has a small portfolio of SBIR, STTR projects. As a matter of fact, this is the only FY 21.1 topic that we have under PEO carriers. And this topic is titled Extended Life and Low Maintenance Aircraft Tie-Down Fitting. So the goal of this project is to, or this topic I should say, is to come up with a tie-down fittings or aircraft deck tie-down fittings that are more corrosion resistant and longer lasting than the current version. So these tie-downs we call star-shaped type 8, as shown on the left-hand side. We have on the flight deck of an aircraft carrier, we have we use anywhere from 4 to 12 of these deck tie-downs to secure an aircraft. And so we have a large number of these deck tie-downs installed on a carrier flight deck, and and a high failure rate or high failure of these deck tie-downs due to corrosion and material degradation, as you can imagine, can create a significant maintenance burden. So the desire is to come up with a new tie-down system that's a form-fit function replacement that has improved corrosion resistance and longer lasting, but at the same time meets the welding and the pull strength requirements that are specified in the Navy drawing for these tie-downs. So once we have a new and improved version of these deck tie-down fittings, for transitioning technology will involve working with our colleagues at In-Service Carrier Program Office, PMS 312, which will likely be the acquisition sponsor of this item. And I'm the topic author as a technology manager, and the other topic author for this is Mr. Jaime Cruz. He's at Naval Warfare Center, Philadelphia. Basically, they're the in-service engineering agent for this item. So this is just to give you an idea or example of the type of SBIR topics that are put out by PEO carriers. And I had a chance to learn about a lot of the new technologies, system development by the small businesses through our one-on-one session earlier today. And in closing, I just want to comment that we're always interested in learning about new technology or systems that would help to support the maintenance and construction of our great aircraft carriers. So certainly you as small business play a great role in that. So I just wanted to close out with that comment. And at this time, I want to turn it over to Del. Thank you, everyone, for listening.
Thank you very much, Richard. Next, we have Roberto Sanchez. Roberto, if you want to go ahead and take it away.
Oh, good afternoon. My name is Roberto Sanchez, and I'm the technology manager for Team Submarine. So, Team Submarine is the Navy's submarine research, design, acquisition, modernization, and maintenance organization. So that's what we do here at Team Submarine. Now, looking here, this is my rough org chart because just a little bit over a year ago, Team Submarine underwent a reorganization to better meet our mission. But as a result, we have yet to generate a org chart that is not for official use only. So, given the venue, I went ahead and I drew this simple 3-block diagram because it identifies how the result of that reorganization divided us into 3 main parts. The first is the submarine in service, better known as CO7. CO7 is headed up by Admiral Anderson. So some comments, being in submarine in service, some common areas of interest for him are overseeing the logistics and the training for the fleet. He also is vitally engaged with the in-service maintenance and repairs to make sure our submarines get in and out of the maintenance availabilities on time. It also covers the submarine escape and rescue, as well as with other aspects that the in-service submarines are also concerned with, is getting our special operating forces to and from theater, so soft undersea mobility. And last but not least, that's one of the focus areas of CO7 is subsafe certification. Has to ensure that all of our submarines are certified and ready to go to sea. The next two branches are each called Program Executive Offices, or PEOs. The first one is PEO subs. Correction, well, it's PEO subs. It's known as PEO subs. It's PEO submarines, and that's headed up by Admiral David Goggins. He's chartered with bringing in new technology and maintaining legacy technology for the employment on submarines of today and tomorrow. So now brings us to the third block. So why do we have a second PEO? Given that Columbia is the #1 acquisition priority for us, the PEO Columbia was created to ensure on-time delivery to meet the nation's strategic deterrence needs as the legacy Ohio-class submarines begin to go offline. Knowing that this is the #1 priority, Columbia needs to be delivered on time without delay, so that we can meet our strategic deterrents. PEO Columbia is headed up by Admiral Scott Papano. So, right, instead of having, what I can't show you here because it's still for official use only, is that instead of having duplicate offices, PEO Sub and PEO Columbia share resources, which allows PEO Columbia to focus on Columbia specific concerns and getting her ready to meet the fleet. Next slide, please. Here I present a laundry list of historical items as well as areas of employment within Team Sub. While I don't intend to read down this list, you can see that we cover a wide range of areas. Of interest, you can see that for in our BAA, we cover items that are such as submarine escape, which is as you can see is one of the items listed there. We're interested in ensuring that we can increase the probability of a buoyant escape from an individual if necessary from a submarine. And also there's another topic under submarine escape where we're looking for technology to assist with controlling gases that collect in the submarine during a casualty or fire. These would be systems that would operate independent of the ship's power and can operate under any casualty condition. I also like to call out. You notice that the first two topics up there are Virginia class and Columbia class. We have a topic in our BAA, which is intended to assist on the design process, because right now we don't really have a mechanism when we design a ship to understand fully what corrosion properties we have when we connect two different types of material together. We're looking for a company that can generate a program that can go ahead and read the CAD designs as they're being developed, and then having a database of known corrosion mechanisms is able to flag for the designers, hey, you just designed this using metal A and metal B. You know that's going to cause a big issue down the road. You're baking in an issue for corrosion. Well, then that gives us, at the very beginning, we can try and redesign it so that we're using a different material that will not end up buying us a big corrosion headache later down the life of the ship, and all of that would end up minimizing maintenance costs and increasing the availability of the ships to our fleet. Those are the two the few topics that I wanted to bring up. I'm thankful for your attention, and I'm ready to turn over the rest of my time to Del. Thank you.
All right, thank you very much, Roberto. So last today we have Sean Slade and Larry Branthover from Navair that are going to talk about their topics. So take it away, guys.
Good afternoon. Can you hear me?
Yes, we can hear you fine.
Okay, good. Good afternoon, everyone. I'm Sean Slade, Assistant PEOA for Science and Technology from the Naval Air Systems Command Headquarters, Navair for short, up at Pax River, excuse me, up at Patuxent River, Maryland. If you provides full life cycle support of naval aviation aircraft, weapons, and systems. The current PEOA, so Air ASW Assault and Special Mission Programs, is Major General Mazziello. So I'm a former Navy H-60 pilot by trade. I used to conduct ASW warfare out in the fleet, so getting innovative solutions out there quickly is my utmost priority. I'm a Navy grad, so I'd be remiss this week if I didn't say go Navy, beat Army. The game's on Saturday, so tune into that. PEOA is comprised of 10 major program offices, or PMAs, as you've probably heard from NAVC and NAVWAR. Our first program office, sorry, if you want to go to the next slide, Del. I don't know if I can. All right, you can see some of the products there. I think I've already mentioned some of them. Go to the next slide. We're going through we've been reorganized. Some folks are maybe familiar with our old organization being a competency-aligned organization. This is a new mission-aligned organization construct that got rolled out earlier this year. You can see how the PEOs that I'm a part of, PEOA, the second blue box from the left there, is supported by the different warfare centers, NOC-AD, COMFRC, and NOC-WD out at China Lake. And then the headquarters groups provide those standards and allocates resources and support across the PEOs as well. So just a quick operating construct. Go to the next slide. There's the PEOA program. So PMA 261, you're probably familiar. That's the H-53 heavy lift program office, heavy lift helicopter program office. It's had the MH and CH-53 legacy and the new CH-53. PMA 264 is our Air ASW Systems Program Office, mainly focusing on sonobuoys, but they're bringing in some other non-traditional ASW technologies as well. PMA 275 is our V-22 Osprey Program Office. PMA 276 is our Light Attack Helicopter Program Office. That's the H-1, the UH, and the AH-1 Marine Corps helicopters. PMA 299 is office, so the line of H-60, both the R and the S is supported through that program. PMA 290 is the Maritime Patrol and Reconnaissance Aircraft. So that's the legacy P3, EP3, and P8 platforms are supported through there. PMA 271 is Airborne Strategic Command, Control, and Communications. So the E6B program office. PMA 207, Commercial Transport and Support. C-130 and C-9. That's the range support and other commercial support and airlift program office. And then last but not least is PMA 274. That's the Presidential and Executive Lift Helicopter program office with the VH-92 aircraft and the legacy H-3 and H-60. So each of the programs have a small business advocate. I think NAVC has mentioned that, which also have advanced development or science and technology leads. For all of the topics that we put out in the broad area announcement, there's at least one program endorsement, and I will say that it's their number one topic or number one kind of head herder that we want small business to address. So all of these are kind of our top priorities. And then in a lot of cases, what we try to do is optimize the broad area announcement by making these topics applicable to more than one PMA or program office. So these are potential head herders for our PMAs. So you should key in on that. I think I mentioned the deputy program manager and the science and technology leads in each of the PMAs. That contact information can be made available through the summit host as desired. Mentioned, obviously, I'm from Navair. So our Navair Command Strategic Initiatives from Admiral Peters are, first of all, improving the current and future readiness of naval aviation aircraft. And then secondly, accelerating the delivery of capability to the fleet. So you'll announcement that follows the themes for our PEOA topic is trying to get improving current and future readiness, and then also getting capability out there. So if you look down through, if you go to the next slide, please. You'll see the theme, the first theme here, naval aircrew specific body armor. There's aircrew really strongly desire the capability to jettison the buoyant armor and water survival situations, as you might imagine. It's sometimes heavy, it's negatively buoyant, and can get in the way of their egress. So this is one of the areas that we want to optimally design and develop some innovative, affordable body armor so that aircrew can get out of the aircraft successfully. The second topic. This topic applies to 22 programs, and it's a tool to predict the transient spatial temporal boundary conditions for autoclave cured composites. Obviously, with the 53K coming out, it's a mostly composite aircraft, as well as the V-22, as well as several others. And so our ability to process and cure high quality parts is of the utmost importance. So we need an analysis tool to help us out, understand what's going on in those in the autoclave and those thermal and mechanical, and make sure that we get a good quality part out of that. So this is obviously a readiness topic. So next slide. So the next area, we have a lot of demand signals from our AirASW community, or that side of the portfolio. This one came from PMA 264, as you can see. And search using multi-static active sonar. Our multi-static active systems are relatively expensive to deploy. So we need simulation and a way to optimize the ping through simulations instead of deploying them out and working out the tactics that way. So that's an area ripe for innovation. So next topic. The next topic applies to our H-1 helicopters, PMA 276. Full-scale fatigue, all new aircraft designs. While the aircraft are subjected to this testing, rotary wing aircraft often prove to be much more difficult to evaluate because of high cycle counts that the airframes experience. So that kind of puts a limit on, from a time perspective, how many articles that we can test and some of the tests that can be done. So what we need here is to develop an adaptive model-based test frame control system that increases the load cycling frequency while maintaining the load accuracy for the high-speed dynamic rotary wing airframe test. So once again, a readiness topic. Next topic. This one's for our P8. So to provide assured comm, off-going P8 aircraft on station, we'd like to have a free space optical communications that can exist in any kind of weather conditions. So that's pretty challenging if you're aware of that area. It's got to be high data rate, it's got to be low latency, wireless, obviously mobile communication. So that's a key research topic for our P8 community. You get to the next slide. I talked about multi-statics. So this is actual sonobuoy improvements for multi-statics. There's a lot of different portions of a multi-static active sonobuoy that could be improved, either acoustically or adding non-acoustic sensors to the multi-statics to get improved detection, classification, localization performance. The next slide. This one has sparked some interest. Non-traditional airborne ASW systems. So for, and this is specifically from the 264, which is the Air ASW Systems Program Office, but it also applies to the P8 aircraft. And you can see what the objective there is to design and develop a non-traditional airborne ASW system capable of detecting quiet submarines from high altitude. So we'd like to explore some alternative non-traditional concepts. Obviously, submarines are getting ever quieter, so we'd like to have, and the folks that are in this area are very aware of what some of those signatures and other things that could be detected from submarines are. So we'd like to get some help from the small business community in that area. The next slide. I'm actually going to skip over this one, but once again, a readiness topic. And then the final one that I'd like to talk about applies to our PA program office, and that's the combined electro-optics infrared radar sensor system for detect and avoid for non-cooperative small UAS. So it becomes a problem out in airspace. We have many cooperative systems for detect and avoid, such as traffic collision avoidance system, the ADSB, but this is for those small UAS so that we can detect and avoid and stay away from or know when they're operating in close proximity to our large aircraft. So that is both a capability and kind of a readiness topic. Now I'd like to turn it over to my colleague Larry Brandhover from PEOT, which is the Tactical Aircraft PEO, and so he can talk about some of their needs. Larry?
The PEOs are with the S&T community, the engineering community, private industry, as well as many of the
Larry, you're breaking up really, really bad.
Oh, okay. Let me turn off my camera.
Sean, it seems like we're having issues with hearing Larry. Is there anything you can say about the POT area or?
Hello? Hello?
Okay.
Okay.
I got you.
Okay, you got me now? All right.
Yes.
You know, I know there's a lot of the common needs. In some cases, across the PEOs, what we really try to do is look for topics that resonate, not only with PEOA but PEOT. And I know, do we have them back now? I know the free space optical one that had a lot of interest from PEOT as well. If you jump to that. low latency, high data rate comms in a in a challenged environment. That was something that was supports our PEOs. Trying to see other ones. Yeah, sorry, I wasn't prepared to speak to his slides, but maybe if you can flip through, if he can't get the voiceover for him, at least you can see what the topics are.
I just reconnected.
Yeah, Larry, you sound like a bad robot from a 50s science fiction movie.
Okay.
So what I'll do is I'll slowly flip through the next slides here because we're running a bit low on time for the rest of this panel. But so those are the some of the interesting areas that the Navy has available for technologies that actually just dropped in the 21.1, 21.A pre-release. So we keep this moving. We're actually going to move into our next and final session of the day, but I definitely want to thank all of our Navy program managers for being able to join us both for the one-on-one sessions as well as for this dive through about what do you need to know about working with the Navy, how do they operate, and what are some of those very unique opportunities for moving forward. But, thank every one of you again. We greatly appreciate you making time to talk with the small business community about your opportunities, how to work with you, and for those one-on-one sessions that many of you participated in this morning. But hang on one second, folks. We'll be right back with our very final presentation of the day.